Hello, I am Dr. Ramakrishna. I did PhD in theoretical physics in 1991. Since then, I am teaching physics for IIT JEE aspirants. In the earlier classes, we discussed about the simple harmonic motion. Today, we are going to discuss its role in understanding the wave motion, like sound waves, transverse waves and all. So, today I am going to start sound waves. What is a sound? We know that sound is a form of mechanical energy, Okay? It is a combination of potential and kinetic energy. Who is the source of sound? A vibrating body is the source of sound. Any vibrating body is a source of sound. For a propagation of the sound energy from one place to other place, what are the requirements needed? Since sound wave is a mechanical wave, a medium is required for its transmission. A medium is required. Not only the medium has to be elastic medium and inertial medium and non-viscous medium. So, a particular medium only can propagate a mechanical wave. Let us say the source of sound is a tuning fork. Source of sound is a tuning fork. When you vibrate this tuning fork, it will be in SHM. Let us say it is a source. Okay. Somewhere there is observer. So now it is a source of a mechanical energy which is produced when it is vibrating, that has to be received by this observer. So, in between source and observer, a medium is required. In between, let us say air is present. From here to here, air is present. So, the medium between source and observer is air. Fine. The pressure in normal condition is 1 atm. So, we say 10 to the power of 5 pascals. The pressure in normal condition is 1 atm, which is approximately 10 to the power of 5 pascals. And we know that the density at normal condition, let us say density rho is equal to nearly 1.29 kg per meter cube. The density of air in normal conditions, 1.29 kg per meter cube. This is a normal density, is a pressure, normal pressure. Now, let us see what happens. So, it is creating a disturbance. Okay. So, let us define what is a wave first. Okay. Any periodic disturbance is called a wave. Any periodic disturbance. Here periodic means after certain interval of time, same thing repeats, same type of disturbance repeats. So, what is varying periodically? Here, as for a propagation of sound, we need a elastic medium. What do you mean by elastic? When you apply deformation force, there is a deformation. When you remove the deformation force, you should come back to the original position or original shape or size. That is called elastic medium. So, air is elastic medium. Then how do you measure its elasticity? For a propagation of any sound wave, we need elastic medium. But first you should know the elastic nature of this medium. So, what is the elasticity of the air? Since we know that for liquids and fluids, we have only a bulk modulus B. Let B is the bulk modulus of air. B is the bulk modulus of air. What is the bulk modulus? Let us try to calculate the bulk modulus of air. When source creates a disturbance, when it moves towards right, a region is formed. A region is formed in the medium where pressure is slightly more than normal value. The pressure is slightly more than the normal value. We call this as compression. We call this as compression. Similarly, when it moves towards left of mean position, a region is formed which is slightly less dense and less pressure zone. P naught minus delta P. When source completes one oscillation, one compression and one rarefaction is formed. Okay. Compression is a region where pressure is slightly more than the normal value. Rarefaction is a region where the pressure is slightly less than the normal value. So, when it oscillates, a series of compressions and rarefactions are formed in the medium. A series of compressions and rarefactions in the medium. Okay. These series of compressions and rarefactions, when hit our ear drum, we feel sensation of hearing. Okay. So, now since it is an elastic medium, okay, so the medium is compressed, that is there is a bulk stress experienced by the medium. Okay. Delta P is the bulk stress experienced by the medium. So, here we know that bulk modulus is delta P by delta V by V. Of course, when delta P is positive, delta V is negative. Okay. When pressure is increase in the pressure, the volume decreases. So, this is the bulk modulus of any medium definition, bulk stress by bulk. Here, what is this delta P? Increase or decrease in the pressure due to propagation of a sound wave through the medium. Propagation of sound wave. Now, what is the B value? Let us try to calculate the B value. When sound wave is propagating to the medium, the compressions and rarefactions are so fast, or the thermal conductivity of the air is very small, we can assume that it is an adiabatic process. It is an adiabatic process. We come across this process in thermodynamics. Okay. So, adiabatic process is the one in which there is no transfer of energy from system to surroundings or surrounding to system. Okay. Here we can assume that due to the bad thermal conductivity of air and the compressions and rarefaction so fast, okay, the process of this propagation of sound is an adiabatic process. We know that the expression for adiabatic process is Pv to the power of gamma is constant C, let us say, okay, where P is the pressure, V is the volume. If I differentiate this, I will get dP by P plus gamma times dV by V is equal to 0. dP by P plus gamma times dV by V is equal to 0. If I simplify this, I will get dP by dV by V is equal to gamma times P. What is this dP? Bulk stress. What is dV by dt? dV by V, bulk strain, which is equal to gamma times the initial pressure. Now, if you look at the definition of B, B is bulk stress by bulk strain. That means the bulk modulus of air is gamma times the pressure of the air. The bulk modulus is gamma times, where gamma is Cp by Cv, where gamma is Cp by C, ratio of two specific heats. Cp is molar specific heat at constant pressure, Cv is molar specific heat at constant volume. Okay. Usually for air, nitrogen is the dominant component, approximately it is 1.4 into initial pressure is 10 to the power of 5 pascals. So, it is the bulk modulus of air, which is the measure of elasticity of the medium. So, before studying the propagation of sound energy through air, we should know the elastic property, okay, because elastic medium only can propagate the mechanical wave. So, this is the bulk modulus is the measure of elasticity of the medium. So, the for air it is gamma times pressure. Okay. Next thing is, now we know gamma value. One more important property for propagation of sound is the medium must be inertial. Okay. The medium must be inertial. As you know that inertia is the property of body or medium which opposes change in the state. Okay. In mechanics, we learn the mass of the body is the measure of inertia. Mass of the body is the measure of inertia. But in case of a continuous medium like air, what is inertia? So, we take mass per unit volume, which is nothing but density, okay, which is nothing but density. Density is the measure of inertia of the medium. Density is the measure of inertia of the medium. Bulk modulus is the measure of elasticity, and viscosity is a non-viscous, approximately we can take it as very small value. So, the rate at which this energy is propagating, that is actually sometimes we can call it as velocity. Okay. The velocity of the sound wave depends on two factors. Velocity of sound wave depends on two factors. One is elastic factor B, the other one is inertial factor. Here B is called elastic factor, rho is called inertial factor. So, the velocity small, let us say small v. Here v is velocity of sound. That is the distance travelled by disturbance in a unit time, that is called velocity of sound. So, this velocity of sound depends on the properties of the medium like bulk modulus and inertia, okay. Inertial factor, that is nothing but density. Now, how do you find relation between these three? Of course, there are various methods. Okay. One of the easiest method which we come across in first year units and dimensions, one of the application of dimension analysis is V, let us V is equal to B to the power of x rho to the power of y. One of the easiest way. You can apply momentum, impulse momentum theorem or other by using wave equation and all. Let us say simplest case. By applying the dimension analysis, by writing the dimensions of left hand side and right hand side, I can calculate x and y. So, if I calculate that, I will get v is equal to b by rho. The velocity of sound v is equal to root of bulk modulus by density of the medium. Generally, velocity is square root of elastic factor by inertial factor. Elastic factor by inertial factor. Already we calculated B just now. The bulk modulus of air, if we assume that it is a propagation of sound is an adiabatic process, gamma times pressure by density. Gamma times pressure by. If I substitute this gamma value 1.4 into 10 to the power of 5 nearly, density is 1.29 nearly, this comes nearly around 330 meters per second. Okay. So, the velocity of sound wave, it is valid only for sound wave. The velocity of sound under normal condition is approximately 330 meters per second. So, velocity depends on the properties of the medium. Through this formula, we can connect to the temperature of the medium. Let me complete that also here only. We know that V is equal to root of gamma P by rho, and PV is equal to nRT. Of course, this V is volume, this V is velocity. I can write P into V is equal to mass by molecular weight of the gas, okay, and V by M by V is density. So, P by rho is equal to root of gamma or you can write in this P by rho, you can substitute the velocity V is equal to root of gamma, P by rho is R T by M. Here what is R? Universal gas constant. T is temperature of the medium in absolute scale, M is the molecular weight, gamma is Cp by Cv. Okay. So, this is the relation between velocity of sound and pressure, the relation between velocity of sound and temperature, same thing. Only thing I am expressing in terms of pressure, here I am expressing in terms of temperature. So, this is the one, that means velocity of sound is directly proportional to square root of absolute temperature. Okay. So, as temperature of the medium increases, velocity also increases.